Hello students, hope you are doing well and also you are studying well during this unlock. Alright, welcome to this video. So today we'll be discussing about the shortcut method of calculating standard deviation. So before we go for this method, we'll discuss a quick recap of what we had spoken about in last couple of videos. So standard deviation by normal method, and before that we had also spoken about mean deviation. So far we have studied all these measures of dispersion starting from range, then quartile deviation, then mean deviation, and now standard deviation. So standard deviation is one very good measure of dispersion, and it goes under a statistic treatment, a rigorous statistics treatment, and due to which it is still used to compare any kind of two data sets. If the standard deviation is compared, then that will give us the idea about the spread of the elements around the arithmetic mean of that particular distribution. We have seen already how to calculate standard deviation by using normal method. Now we'll see how we can calculate using shortcut method. So it is the same method. We have already used one shortcut method to calculate arithmetic mean. So here also we have to apply the same method. Anyways, what we require in the standard deviations is all the deviations of the elements from the arithmetic mean. And to calculate arithmetic mean, we have to apply the shortcut method. So that itself is the shortcut method of calculating standard deviation as well. So the basic formula remains same, that the squared deviations divided by the total number of frequency. So this ratio, whose square root is nothing but standard deviation. Okay. So then in this case also we find first the assumed mean and then deviations from the assumed mean. Then those all deviations are squared. Now in this shortcut method we have to multiply frequencies to both with deviations as well as with square deviations, and those both the summations are considered. Now what happens when you assume mean? It is most of the times it is not the actual mean. So when you assume mean, we have to assume it in such a way that we should try to go near to the actual mean by studying the frequency pattern. Then to compensate the distance between the assumed mean and actual mean, so what happens in the standard deviation shortcut method, that the deviations from the assumed mean which are squared, from that the deviations from the assumed mean which are not squared are subtracted. So this way it compensates and it takes you still more near to the standard deviation, though we have applied the method, the shortcut method of assumed mean, which in short we are going to apply to calculate the standard deviation using shortcut method. So the formula for standard deviation using shortcut method is this way. Symbol, this is the symbol for standard deviation. The square root of deviations which are squared, their summation divided by the total number of frequency. Okay, this remains same from your base formula. Now from this, now these deviations whichever we have are from the assumed mean method. So from this, the deviations which are not squared, I mean only the deviations divided by the total number of frequency, this ratio's square we have to subtract from this ratio. So like only deviations which are not square divided by n. So this ratio and its square will be subtracted from this. So this is how we calculate the standard deviation by using assumed mean. So now we'll take one example. Okay, the numbers are given this way. and we need to find the standard deviation of this. So here the actual elements are given, okay, and frequency is not given. It's a raw discrete data. So starting from 22 to 33, so these are the numbers we have. Now first thing, we have to find the arithmetic mean if you go by the normal method, and now we are going by the shortcut method. So we have to assume one mean value for this one. Okay. Now in this case what happens? So if you want to find the assume the mean value, so we have to use a common factor. Now look at this example, 1, 2 and 3. So among this 1, 2, 3, what is the mean average of these three numbers? It is 3, which is 6 divided by 3 gives you 2. So the conclusion is, when we have, what you say, the numbers arranged, then you can expect the arithmetic mean in the central part. Now what if, now in this case what happens? This gives you 16, and 16 divided by 1, 2, 3, 4 gives you 4. Now your okay. Okay, instead of 10, if you had 1, 2, 3, then what arithmetic mean this will give you? This will give you 10 divided by 4, that will give you 2.5. Okay, so you have to, first thing, arrangement is important, and in that arrangement we can expect in the middle part. But here what had happened, the last element has got magnitude much greater than the previous one. So the differences, if you understand, here it is 1, here it is 1, and here it is almost plus, here it is 7, plus 7. So what happens to the arithmetic mean? That mean also gets deviated towards the higher magnitude. But in this case, the increase in all four of them is same, constant. So you get the arithmetic mean in the exactly central part. So these properties you need to understand, and then you have to choose the mean which we assume as a mean. Okay, so I just cannot use any value randomly as arithmetic mean. I have to look for the arrangement of the elements. Also, I need to understand their increments, how they are happening. Then in the central part, I may choose any one of the mean as the assumed mean. And in the case when frequencies are given, then obviously we have to consider the frequency pattern. Okay, now in this case, these all, okay, now after you look at these elements, 22 and 24, there is the increment of 2 here, then 24, 25, 26, 27, 28. These all are increasing by 1 each. Then there is increase of 3 here, and again increase of 2 here. Okay, so then if you consider this, then these two are the middle elements. Okay, 26 and 27 are the middle elements. So actual arithmetic mean could be 26 or 27, or in between 26 and 27, or it could be 26 point something. We don't know the actual mean. Now how we are going to choose the assumed mean method? Okay, assumed mean, how we are going to choose? I have to choose either 26 or 27. I am really not interested to go for 26.5. The reason is we are applying shortcut method. If we consider the fractions here, deviations also will get in fractions. Those fractions we have to square, and we have to also multiply with frequencies. Now in this case there are no frequencies, so better not to go with fractional. So either I have to choose 26 or 27. Now considering this, the second half, where I have got here plus 2 and plus 3 and plus 2. So I may assume that though 26 and 27 in between there could be the arithmetic mean, but because of these two elements, arithmetic mean would go towards right side. So that's the reason, instead of going in between 26 and 27, and also to avoid the fraction part, I would choose my arithmetic mean as 27. So I have chosen my arithmetic mean, or I have assumed mean as 27. Now let me calculate the x minus a. Okay, the deviations from assumed mean x minus a. So let me call it as x dash. So I get values here this way: minus 5, minus 3, minus 2, minus 1, 0. This is 1. This is 4, and then this is 6. All right. So these are the deviations we have calculated. Now we have to square these all deviations. So square deviations would be, this would be 25, then 9, 4, 1, then 0, 1 again, 16, 36. So these are the squared deviations I have calculated. Okay, next we have to find the summation of both of them, that is x dash as well as x dash square. Now you remember always when we are calculating standard deviation, we are considering both the negative fluctuations as well as positive. So x dash will always have starting with the negative values, then in 0 or the minimum value in the center, then positive values again increasing. So this way only we get the x dash values. Now we have to calculate the sum of them. So now look at this. We have got negative values and then positive values. So this gives me minus 5 plus minus 3 gives me minus 8, minus 10, minus 11. So summation of all these would be minus 11, and summation of all these, that is 6 plus 4 plus 1, would be plus 11. So this gives me minus 11 and this gives me plus 11. So summation of them would be 0, and which is a very good sign. So this is one property of arithmetic mean. So when you have the items and its actual mean, then the deviations from the actual mean, the sum of all those deviations from the actual mean are always 0. And we have got 0 here. That means the assumed mean which we have assumed as 27 is the actual mean of these all numbers. Otherwise we would not get 0 here. Okay, so deviations from the actual mean, their sum is always 0. You please remember this. So whenever you get the value 0 or much near to 0, that could be negative or positive, that means you are more near to the actual mean. And when you get summation of deviations as 0, that means it is the actual mean. The assumed mean what you have considered is the actual mean of this entire deviation, entire distribution. Okay, so now next thing is we have to calculate this summation of the x dash square. So this gives me 92. Okay, so from the given value, first we have to find the capital N. Capital N, the total number of elements. So number of elements here are 8. Then summation of x dash is 0. Then summation of x dash is 22. Alright. So these are the values we have got. Now we have to substitute these values. Summation of x dash, and its, hope the substitution is very much clear. 92 is the summation of x dash square divided by n, capital N is 8, minus summation of x dash is 0 divided by 8, and its square we have found. Now 0 divided by anything is 0 and square of 0 is 0. So we will not have any subtraction. So we'll have only the square root of 92. So this gives me 11.0 So square root of 11.5 would be the standard deviation. And if you find the square root of 11.5, that will give us something in between 3 and 4. 3 square is 9 and 4 square is 16. So let me check in the calculator. Square root of 11.5. So this gives us 3.39. Deviation we have 3.39. So this is how we calculate the standard deviation using the shortcut method. So all thing is like you have to first take the assumed mean, calculate the deviations and square the deviations. Then we have to find the summation of deviations and summation of square deviations. Now we'll see when discrete data is given along with its frequency, how do you calculate standard deviation? Okay, so in that case, our formula changes a little. Okay, so standard deviation is factor summation of dash divided by n the whole square. Okay, the standard deviation when it is given along with the discrete data along with its frequency. Okay, so we'll take one example using shortcut method when discrete data is given with frequency. All right. So the given data is this way. X is given along with its frequency. Hope you know the meaning of this distribution. 6 is there 7 times in the distribution. 9 is there 12 times in the distribution. 12 is there 19 times and so on. So this is the given data. Now we have to first assume one mean here, one value as arithmetic mean, and then we have to calculate the deviations. Now if we look at the frequency pattern is totally normal. Like it is first 7, then 12, then 19, 10 and then 2. Okay, it increases, goes to the maximum, then decreases. So the frequency pattern is absolutely normal. Now in this case, if you consider the middlemost frequency 19, which is the highest frequency, then along with that, on both the side of 19 we have got 12 on and then 10. Then and other two sides are 7 and 2. Okay, so now if you look at the first half and second half, the first half makes 12 plus 7 19 and the second half makes 10 plus 2 12. So on the both the sides of 19 you have 19 elements in the first half, then the central frequency and then 12 elements. So though it is normal frequency, we have more magnitude towards left side. So the actual mean of this would be very much near to 12 but will not be definitely equal to 12. Why? Because the first half is having more magnitude than the second half. So the actual arithmetic mean would be near to 12 but it can be little less than 12. Okay. But then again, in the assumed mean method, we just assume one integer value as arithmetic mean. We are not looking for the fractional part. Anyways, we have as per the formula to compensate that if this square value we remove from this, then we can get the actual standard deviation as well. Okay. So now, as per the frequency, it is also in the central frequency is 19, it is maximum, and other two sides are also dropping. It's very much clear that our assumed mean is 12. Okay. So let me say our assumed mean is 12. Then first let me calculate x minus assumed mean, that is deviations from 12. Okay, so 6 minus 12 gives me minus 6. 9 minus 12 gives me minus 3. This gives me 0. This gives me plus 3, and this gives me plus 6. So deviations are very much clear. Okay, so now if you look at the deviations, we have got minus 6, minus 3, 0, 3, and then 6. So among all these values, 6, 3, 3, 6. So I can say the common factor among all of them is 3. Okay, so what we can do with the common factor? One, I'll take one common factor 3, and that I will divide to all of them. So all of them are divided by the common factor. So what happens? In results we get a very small number. And when you get a small number, then it will be easy to square that small number, and then both of them you multiply with the frequency. So if you go ahead with this one, okay, and if you multiply with the frequencies, you will get a larger value as compared if you reduce them by the common factor, you will get the smaller numbers, and those smaller numbers will go on multiplying with the frequencies. Okay, so my deviations now, divide them by 3. So this gives me minus 2, this gives me minus 1, 0, 1, and then 2. Okay, so hope you are clear with this. Here we have taken one common factor called 3, and that we have divided. So all these values, all these deviations we have divided by 3. So now our common, okay, now our x dash values are ready. So let me square all of them. So I'll have, so squared values are 4, 1, 0, 4. So squares of all of them, minus 2 square. So square of any negative number is always positive. So it is minus 2 square, minus 1 square. Similarly, the other three values. Next thing is, we have to multiply the deviations and also the squared deviation with the frequencies. Okay. So now these deviations have to multiply with, so these frequencies I have here. So 7 into minus 2, then 12 into minus 1, 19 into 0, then 10 into plus 1, 2 into plus 4. Okay, so we have calculated the fx dash. Next thing is frequency fx dash square. So square deviations are always, all of them are positive, so you will get always the positive values in the fx dash. So this 7 into 4, and then 8. Okay, two values you get same only the first two values you get different. Alright, okay, so our fx dash is ready as well as fx dash square is also ready. So now the thing is, what all things we require as per formula? We require the capital N, that is the summation of all frequencies. So let me calculate all frequencies. So this gives me 50. So our value of capital N is 50. Then I need to calculate summation of fx dash. So fx dash, okay, now look at this. This gives me plus 18 and this gives me 26. Okay. Uh, so this is 2 into 2, 4x. Yeah, f into x dash 4. This is 10, this is 0, minus 12, minus 14. Okay, so this gives me 14 and this gives me minus 26. So 14 minus 26 would give you minus. Okay. Then next thing, fx dash square. So here, we got minus 12 and 58. Now we will substitute all these values into the formula. So 58. The function of, sorry, the capital N value is 50. Then hope this substitution is clear to you. Common factor is 3. 50 is this is summation of fx dash square. Capital N is 50 and minus 12 is the summation of fx dash. Now let me calculate these two separately, just the fractions. So 58 by 50 1.16, then minus 12 by 50. Minus 50 gives me minus 0, minus 0.14. So the square of 0.24 is, we get the square of 0.24 is 0. Okay. Square of negative would be positive, but outside we have negative, so that makes it always negative. So 1.16 minus 0.0576. Now we have to find the square root of 1.1024. So let me calculate using scientific calci. The square root of 1.1024 is 1. So we have calculated the value of standard deviation as 3.147. Okay. So this is how we have to calculate the standard deviation using shortcut method. So it goes with this only, give assumed mean. We have to find the assumed mean, find the deviations from the assumed mean. Those all deviations we still reduce by using the common factor method. Then whatever you reduce it by, that factor we have to multiply. So this is the important here, that please remember, common factor which you use to reduce all the deviations has to be multiplied later with the value when you calculate the standard deviation. Okay, so now in this case we consider the common factor as 3. So the need for the common factor is, when we reduce the values of deviations, then later it is easy to square them and also to multiply with the frequencies. Alright, so this is, now we'll go for the next example where we'll have the class intervals given along with their frequencies, and then we have to find the midpoints, assume one value as arithmetic mean, and do the same procedure again. Okay, so we'll go for the next example where class intervals are given along with their frequencies. Welcome back. Now this example is with class intervals along with frequencies given, and here we have to apply the shortcut method to calculate standard deviation. Now if you look at this frequency pattern as well, that it is 8, 12, 18, 32, 10, 16, 4. Okay, so this frequency pattern also looks completely normal, starting from 8, then 12, 18, 32, 10, 16 and 4. This way it is. So the 300 to 500, these two are actually, okay, this class is the middle class, the central class having the maximum frequency. You can expect the value of arithmetic mean from the same class. Now if you consider the first half and second half, so this gives us 30 and this gives us 38. So the midpoint of this would be 450. So arithmetic mean would be little less than 450. This is what you can expect. Okay, so as of now, first we will find the midpoint. So midpoints, we know that it is summation of these two limits divided by 2. So summation of 200 and 300 divided by 2 will give us the midpoint. And once you get two midpoints, then you can go on adding the width of the class, you will get the next midpoint. Okay, we have calculated all the midpoints. Now we had considered that this is our central class with highest frequency, then we can have the arithmetic mean in this class. So now our assumed mean would be 450. So due to the frequency pattern, we'll consider our assumed mean. So to calculate x, or you can say the midpoint 450. So this gives me minus 300. This gives me minus 200. So these are the deviations we have calculated. Now among this I need to check whether do I get any common factor. Now in this case there is a restriction here, whatever is the width of the class, that itself you have to use it as the common factor. So it is denoted as I, that is nothing but the width of the class. So now all these values I have to divide by 100. So my x dash, now I'll be gives me, then we have to square all these values, the x dash values which we have calculated. So this, so this gives me 9 square 4. Okay, so I have calculated the values of x dash square. Alright, our deviations which are reduced are ready and the squares are also ready. Now we have to multiply both of them with frequency. Okay, so I'll have a column called as f. Right? So fx dash is this x dash values multiplied with frequency. First one gives me 8 into minus 3 minus 24. And 12 into minus 2 also gives me 24. 8 into minus 1 gives me 18. 32 into 0 is 0. Then 10 into 1 gives me 10. 16 into 2 gives, and the last one is 4 into 3 gives me 12. Okay, so my values, fx dash values are ready. Next, fx dash square. So frequencies we have to multiply with square deviations. Okay, so these are the values 94101. These we have to multiply with corresponding frequencies. So first one, 8 into 9 gives me 72. Then 12 into 4 is 48. Then gives me 18. Next would be 0, 10, 64, and the last one is 36. Okay, so all my values are now ready. Now I need to find these values we required in the formula. I is our common width of the class, which is 100. Okay, then fx dash square, summation of fx dash square I need to find out. Summation is this way. Forty-eight. Okay, then summation of fx dash we will find out. So now these minus values, that is 24, 18, gives me minus 66, and this gives me plus 54. Okay, so 54 minus 66 would give me minus 12. Again we have got minus 12 in this example as well. Okay, now let me calculate summation of all these. Frequency summation is 100, so that's good for our calculation. Okay, so we have calculated all the values required. So let me substitute one by one into the formula. So width of the class is 100 into the bracket summation of fx dash square, which is 248, divided by 100, that is our total frequency. Then summation of fx dash, which is minus 12, again divided by 100, and square of this ratio. Hope you are clear with this substitution. It is 100, 248 divided by 100. This is minus 12 divided by 100. Okay, so due to 100 denominator 100, our calculation is very simple. 248 by 100 gives me 2.48. Minus 12 by 100 gives me, okay, so square of 12 is 144. Yes, so 0.12 square would be 0.0144. So this would be difference 2.48, 0.0144. 2.4656. Okay, so I have to find the square root of 2.4656. So let me calculate the square root using scientific calculator, which is 2.4656. So that gives me 1.57. Gives me 7. Alright, so hope you have understood how we have calculated this value. So the final value of standard deviation what we have calculated is 1.57 into 100, which is 157. Alright, so we have to remember that we have to apply assumed mean, find the deviations, then those deviations has to be divided by the class width. So this is the rule. Then after you divide it by the class width, you get the smaller deviations. Those has to be squared, and then both of them has to be multiplied with frequencies. Then their summations we use into the formula, and then the factor which we have used, I mean the class width, again that has to be multiplied with it. Okay. So we have got the standard deviation as 157. So that means most of the values of the entire distribution are minus 157 to plus 157 from the arithmetic mean are distributed very densely, and they make the most of the distribution, most of the contribution towards distribution. So hope you have understood the meaning of standard deviation as well, how standard deviation helps us to compare data sets. You have understood this meaning as well as this example. Now by using the normal method also you can check and verify whether you get the same standard deviation. By using the shortcut method you can try the other examples as well. So you have to practice more, you have to solve more examples, then you will gain the confidence for this subject. So hope you have understood my concern. Then we'll stop here. For the next video, we'll go with the next unit or new concepts. Till then, study well, take care of yourself, follow all these guidelines. Thank you.